Hi guys, in this video I'm going to explain about the set operations. So before going to the set operations, just I will explain Venn diagram. Venn diagram. Venn diagrams are nothing but the diagrammatical representation of the sets invented by John Van Euler. John Van Euler. So diagrammatic representation of set is called as the Venn diagram. Suppose two sets are there which are joint sets A, B. So the representation will be like this. Venn diagram will be like this. So set A is one circle and set B is another circle. If they are joint sets, like that we will represent. Otherwise, if they are disjoint sets, like this we will represent A, B. Otherwise, if they are subsets, like this we will represent. So this is the diagrammatic representation of sets is called as Venn diagram. Next, set operations. Set operations are of three types, or simply we can say that first one union of sets. Union of sets. So union means the set of all elements in the given set without repetition. The set of all elements in the given sets without repetition is called as union of sets. Suppose A is equal to the set 1, 2, 3. B is equal to the set 2, 3, 4, 5. So A union B, union representation is just like U, like this. A union B is equal to the set of all elements 1, 2, 3, 4, 5 you will get. Because 2, 3 are repeated here, so once you have to write. So 1, 2, 3, 4, 5 is the A union B. Okay. Next, so how can you write the A union B in set builder form? A union B in set builder form. So A union B set builder forms already we learned. So element property form you have to write X such that X belongs to A or X belongs to B either in A or in B. So that is called as A union B in set builder form. Next, this only diagrammatically how can you represent? So Venn diagram, diagrammatical representation of A union B. So two sets we are taking set A and set B, and you have to enclose in a rectangular universal set, and that is indicated by mu. Universal set is indicated mu. This is set A and this is set B. So A union B means all elements together in set A as well as set B. So representative region you have to write. Which region represents A union B? The shaded region. So here you have to draw like this. The shaded region represents the A union B. This is about A union B. Union of sets. All elements together without repetition is called as union of sets. Next, secondly, example also understood now all of you. So secondly, intersection of sets. Intersection of sets. So here the set of all common elements from the given sets. The set of all common elements from the given sets indicated by the symbol like this. Intersection symbol is like this. The set builder form of A intersection B is X such that X is an element in the set A and X is an element in the set B. X belongs to A and X belongs to B. So that is A intersection B. That means, for example, you take A is equal to the set 1, 2, 3 and B is equal to the set 2, 3, 4, 5, just like previous example. Then what are the common elements in A and B? The common elements in A and B is 2, 3. So 2, 3 comes under Intersection of elements. The repeated elements only you have to write once. That means the common elements in set A and set B. And here the connective used is and. Previously the connective used is or. Okay. The Venn diagram can be represented like this. Set A and set B. This is the mu universal set A and B. Intersection means only common part. Intersection means only common part. The representation A intersection B. Representative region is shaded region. Or else you can draw this another way also. So that means the elements which belongs to A, that means completely A you can shade. Circle A and circle B. A is shaded with the horizontal lines and B is shaded with vertical lines. Then what is that should be enclosed in the universal set mu? Then A can be written as horizontal lines, B can be written as vertical lines. A intersection B is a double shaded region in the middle part. So this part is this whatever is shaded part. This part becomes the intersection. Intersection of A and B. Okay. Next, difference of the two sets. Difference of two sets. Is represented by A minus B or B minus A. Minus will represent it as minus. That means the elements which belongs to the set A and does not belongs to the set B. In this case. In the second case, the elements which belongs to set B and does not belongs to set A. For example, if you will take, suppose A is equal to the set 1, 2, 3, 4, 1, 2, 3 or else, and B is equal to the set 2, 3, 4, 5. Then the elements which belongs to A and does not belongs to B means whatever the elements are there in B, you have to cancel in A. So what is left over in the set A? Only the element 1, the set 1. So what is B minus A here? The elements which purely belongs to B, you have to write B minus A means. That is 4, 5. And Venn diagram can be drawn like this. A is one set, one circle. B is another circle. Universal set is mu enclosed in a rectangle. A minus B means like this. A minus B is represented by representative region is a shaded region. Shaded region. And suppose B minus A, how can you write? How can you draw B minus A? With horizontal vertical lines in B minus A can be drawn as only B. The elements which belongs to purely B, only. That is indicated by only. So A minus B minus A is equal to shaded region. Okay. So this is the difference of sets. Next coming to, so A union B is all elements together without repetition. A intersection B means common elements, only common elements. And next A minus B means the elements which belongs to A and does not belongs to B. So next symmetric difference. Symmetric difference. Symmetric difference of two sets. of two sets A comma B. Symmetric difference of the two sets. A is B. Suppose this is represented by A delta B. A delta B. So A delta B can be written as A minus B union B minus A, or A union B minus A intersection B. A union B minus A intersection B. That means, for example, if you draw the diagram for this, Venn diagram for this, A is one circle and B is one circle. Those are representing the sets mu, universal set A, B, and next A minus B means you have to represent in the set A only, and you have to represent in set B only. Then this is the symmetric difference. So outline region like this. This is the, so how can you write A minus B as vertical lines and B minus A as horizontal lines? These are called as, this is called as the representative region. Then what is the A delta B? A delta B is equal to A minus B union B minus A. Union means full shaded region. Full shaded region. Full shaded region. So this is symmetric difference. So union is all elements together without repetition. Intersection means only repeated elements once. Next, difference means the set A elements belongs to the set A and does not belongs to the set B. Next, complement of a set. Complement of a set is A complement, like this we can represent, or else A complement, like this also we can represent. It is denoted by A complement or A. So that is nothing but mu minus A. Mu minus A. Mu is what? Universal set. Minus A you have to take. So A complement can be written as mu minus A, and whose set builder form is X such that X belongs to mu and X does not belongs to A. X does not belongs to A, just like A minus B. So A minus B also we discussed. A minus B is X such that X belongs to A and X does not belongs to B. X does not belongs to B. Okay, so the Venn diagram for A complement can be drawn like this. One circle, because only one set in the universal set mu, the circle is A, and A complement is except A. That means other than A you have to shade. Other than A you have to shade. So that is the, so mu minus A is nothing but, A complement is nothing but mu minus A. That can be represented with horizontal lines. The representative region of A complement is horizontal lines. So we discussed union of sets, intersection of sets, difference of sets, symmetric difference of sets, and complement of sets. Next, you have to note that if A is subset of B, subset already we discussed. If A is subset of B, then what you will get? Then what are the conditions? A union B is equal to B you will get. A union B is equal to B. Because already we discussed A is subset of B means A is a smaller set than B. So A union B is the elements belongs to the B you will get. And what about A intersection B? Automatically you can say that is A. And what is A minus B? Wait, fast. Null set. Very good. It is null set. Because A is subset of B. A minus B means every element of A can be cancelled because that is there in the B. So what is A minus B? Null set. Then n of A minus B, what it becomes? So cardinality of null set is what? 0. And next, A minus of A minus B becomes what? A minus of A minus B. A minus B is what? Null set. A minus of null set becomes A. A minus of null set becomes A. These are the important things you have to remember. And like that only, if A and B are disjoint sets, A and B are disjoint sets. Previously we discussed subsets. Subsets I explained. Disjoint means what? A and B are disjoint sets. Disjoint means there is no common element for A and B. So A intersection B is equal to 5 you will get automatically. So what is the first condition you will get? A intersection B is equal to null set. Then what is A minus B? A itself. Very good. What is B minus A? B. So A minus B means the elements which belongs to A and does not belongs to B. There is no common element, that's why you will get A itself. B minus A you will get B itself. Then what is n of A intersection B? What is n of A intersection B? N of means cardinal number of A intersection B. A intersection B is 5. So what is the cardinal number of A intersection B? 0. What is A delta B? A delta B means A minus B union B minus A. A minus B union B minus A. A minus B is A. B minus A is B. So what is A delta B? Union. A union B you will get. Very good. A union B. A union B. A minus of A minus B. A minus of A minus B. What is the answer for this? What is A minus B? A. What is A minus A? Null set. A minus A is null set. Next, these are the important formulae. That means you have to understand this properly. You can solve the sums easily. So you can note down all those things while telling. Next, one more important law. N of A union B is equal to the relation between N of A, N of B and N of A union B, N of A intersection B. So N of A union B is equal to N of A plus N of B minus N of A intersection B. Minus N of A intersection B. So what is N of A intersection B? So N of A plus N of B minus N of A union B. Minus N of A union B. And if A and B are disjoint sets, what you can write N of A union B as? Disjoint sets means no common elements. N of A intersection B becomes 0. So N of A plus N of B. N of A plus N of B. When? If A and B are disjoint sets. A and B are disjoint. Disjoint sets. Okay. What is N of A minus B? N of A minus B. Venn diagrams you have to remember. A minus B. N of A minus N of A intersection B. N of A minus N of A intersection B. A minus B Venn diagram, do you remember? Like this you will get. So this is N of A means complete circle. From that what you are removing? A intersection B you are removing. So what you have to get? N of A minus N of A intersection B you will get. Then what is N of B minus A? N of B minus N of A intersection B. Okay. Next. These are also very important. You have to remember all. So N of A union B is N of A plus N of B minus N of A intersection B. So by transposition you will get N of B minus A is also N of B minus A is equal to N of B minus N of A intersection B. So these are the formulas which are useful in this chapter. After that, we'll go to do this and some problems I will explain in the 2.2 and 2.2. Before do this thing, try this and think, discuss. So suppose for example A is equal to 6, 9, 11, and he asked what is A union 5. So like these problems, the children actually you'll guys you'll confuse with that. So A union 5 is nothing but A is 6, 9, 11. Union of 5 is a empty set, null set, no elements present in that. Union means all together. So 6, 9, 11 you have to write. So that is A union 5. What is A intersection 5? A intersection 5 also 6, 9, 11 intersection null set, empty set is nothing but common elements you have to write in the intersection. There is no common elements. What is the common element? Only null set is the common element. Nothing is the common element. So A intersection 5 is equal to 5 you will get. A union 5 is equal to A you will get. So this is also identity law. A union 5 is equal to A. A intersection 5 is equal to 5. Okay. And like that only you can write A union 5 is equal to 5 union A is also same. That is nothing but A. And A intersection 5 is equal to 5 intersection A is equal to 5. Okay. So whatever you will feel that I am going to explain in all the videos. So remaining things, whatever I am leaving, those are easy. So you can solve them automatically if you understand the concept well. Next, the intersection of two disjoint sets is a null set. Justify your answer. Intersection of two disjoint sets is a null set. Suppose A is equal to 1, 2 is one set and B is equal to the set 3, 4. Both are disjoint sets. No common elements. Then what is A intersection B? Intersection means common elements in the two sets. So any common elements are there in the two sets? No, nothing is common. So what is common? Emptiness is a common. So that is nothing but null set. So A intersection B is equal to null set. So intersection of any two disjoint sets is a null set. And one more thing to discuss. The set A minus B, B minus A minus B, B minus A and A intersection B are mutually disjoint sets. Justify. Okay. A minus B. By taking example, we can justify this. A is equal to the set 1, 2, 3. B is equal to the set 2, 3, 4, 5. And C is equal to S. That's all, two sets. Okay. A is equal to B is equal to two sets we consider. Then what is A minus B? A minus B is the set 1, 2, 3 minus of the set 2, 3, 4, 5. Minus means the elements which belongs to A and it does not belongs to B. So common elements you have to cancel and whatever the elements left in the A you have to write. So the set 1. What is B minus A? B minus A is nothing but the set 4, 5. And what is A intersection B? What is A intersection B? A intersection B is nothing but A is 1, 2, 3. Intersection B is 2, 3, 4, 5. So automatically intersection means common elements 2, 3 we will get. So 2, 3 is the common elements. Now consider what is A minus B? The set 1. What is B minus A? The set 4, 5. What is A intersection B? 2, 3. Any common elements between A minus B and B minus A? No. Any common element between B minus A and A intersection B? No. Any common element between A minus B and A intersection B? No. That's why A minus B, B minus A and A union B are mutually disjoint sets. So exercise 2.2 also you can do. No problem. Already fourth question also I explained in the formula. Fourth question is nothing but A is subset of B. Is A union B is equal to what you will get? Yeah, he's asked. If A is subset of B, so how the elements you have to consider? A is equal to 1, 2, 3 if you'll take. What automatically B elements becomes? 1, 2, 3, 4, 5. Other extra than A. All elements should be present in B. Then A is subset of B. Every element of A should be in B. Then A is subset of B. Then what is A union B? He asked. What is A union B? 1, 2, 3. Union 1, 2, 3, 4, 5. Union means all elements together. You have to write 1, 2, 3, 4, 5 without repetition. All elements you have to write without repetition. So 1, 2, 3, 4, 5. Which represents what? Which set? Set B. So what you can say that if A is subset of B, if A is subset of B, then A union B is equal to B. I explained in the formulas all. So remaining all you can do.